Hello and welcome to our channel. Today we'll talk about the most recent advancement made by NASA's James Webb Space Telescope, or the JWST. In this video, we will go through all of the most recent photographs obtained by the James Webb Telescope in order to better grasp the hidden secrets of our galaxy. So, without further ado, let's get started. What is the James Webb Space Telescope? The first query is, what is James Webb? As a response, the James Webb Space Telescope, or JWST, is a space telescope designed primarily for infrared astronomy. Because it is the largest optical telescope in orbit, its significantly greater infrared precision and sensitivity allow it to analyze objects that the Hubble Space Telescope cannot detect because they are too early, too far, or too dim. This is intended to allow for a wide range of astronomical and cosmological investigations, such as the detection of the first stars and the formation of the first galaxies, as well as detailed atmospheric characterization of potentially habitable exoplanets. On December 25, 2021, the James Webb Space Telescope was launched aboard an Ariane 5 rocket from Kourou, French Guiana. Recent development. We now know what the James Webb Telescope is, and we are ready to move forward. The Webb was designed to capture light from the whole red to mid-infrared spectrum that the Earth's atmosphere blocks. Webb can make photos of extraordinary quality thanks to its enormous mirror and sunshade, which filters infrared radiation from the Sun, Earth, and Moon. The excitement among professional astronomers has been intense since members of the Webb team showed enticing test photos, and the actual images are even more spectacular than anyone could have anticipated. At the conference where the first photos were shown, Webb research scientist Jane Rigby stated, "There is no such thing as an empty sky for Webb. It finds faraway galaxies everywhere it looks. The majority of those galaxies have never been seen before." Early universe. The first image released by Webb was of a galaxy cluster known as SMACS 0723. It is located in the southern hemisphere sky, 5.12 billion light-years from Earth. The detail of thousands of individual galaxies in the photograph is amazing. It's like seeing the universe in high definition. Anyone can examine the full resolution image and zoom in to appreciate the fine details. The large white galaxies in the photograph center are part of the cluster and are roughly the same age as the Sun and Earth. Additional distant galaxies ring and intersperse the cluster galaxies, but they are stretched into spectacular arcs as if seen through a magnifying glass. This is exactly what is taking place. The background galaxies are very far away from Earth, but the gravity of the nearby cluster bends their light toward Earth, making them look bigger. In the background, blazing red galaxies spread across the sky like rubies. Those galaxies are even further away. By looking at certain parts of their light, astronomers can figure out that they formed more than 13 billion years ago. They can also measure how much of certain elements are in these old galaxies. The Webb Space Telescope not only creates incredibly fine images, but it does it more easily than its predecessor, the Hubble Space Telescope, which was released in 1990. Hubble requires 2 weeks of exposure. Webb goes far deeper before breakfast. Rigby laughed. Once Webb conducts extended observations that allow it to gather more light from dim stars or galaxies, astronomers will be able to see some of the earlier stars and galaxies that erupted just after the Big Bang. The second breakthrough was the discovery of a spectrum, which is a breakdown of the brightness of light at different wavelengths. As WASP 96-b, a huge hot gas planet orbiting a star around 1,000 light-years from Earth, passed in front of its parent star, Webb directed its mirror at it. During its transit, a portion of the star's light traveled through the planet's atmosphere, leaving a chemical fingerprint in the light's unusual spectrum. The features of this fingerprint make it clear that water vapor, clouds, and haze are in WASP 96b's environment. Astronomers expect to find the fingerprints of oxygen, nitrogen, ammonia, and carbon in the form of methane and other hydrocarbons as Webb investigates tiny planets that may harbor life. The goal is to discover biosignatures of life or chemistry that show that live organisms have impacted the environment. This type of observation, called transit spectroscopy, is hard to do because it requires a lot of technology, and this first discovery only scratches the surface of what scientists know about the spectrum. As the telescope looked into how stars form and die, the last 3 pictures showed how clear Webb's lenses were. Webb's ability to gather light in the mid-infrared range allows its cameras to penetrate heavy clouds of dust and gas. Thanks to this capability, Webb was able to capture spectacular features of the Carina Nebula, the birthplace of stars. Webb is also well suited to studying the end of a celebrity's life. As stars age, their surface layers can erupt and form nebulae, such as the spectacular Southern Ring Nebula, which Webb observed. The image revealed previously undiscovered features of the dying core star's successive waves of material. Hubble couldn't see through the nebula's growing cloud of dust and debris, but Webb was able to take the first picture of the 2-star system. In the final photo from Webb's farewell party, Stephan's quintet, a cluster of 5 galaxies 300 million light-years from Earth, mingled in a cosmic ballet. The telescope can instantly see the details of individual stars in these galaxies. Imagine coal dust and gas that helps planets form in these galaxies, and, most impressively, block out the stars, gas, and dust to see the material swirling around one of the galaxy's supermassive black holes. Webb also got spectral data from hundreds of different places in the quintet where stars are being made. This will take months to look into and study. Webb is the result of 25 years of work by hundreds of scientists, engineers, and government officials from a global alliance of space agencies, companies, research institutes, and universities. Webb project manager John Mather described the journey passionately. This was a difficult assignment. It's difficult to put into words how upsetting this was. There were literally thousands of different scenarios available. However, nothing went wrong. Everything fell into place precisely, and humanity's greatest space telescope is now functioning. I hope you liked the video. Please like and subscribe to our channel. Thank you.